Hello everybody, my name is Luca Aiello and I work at Nokia Bell Labs in Cambridge. So Bell Labs, for those who don't know, it's the research branch of Nokia. So today I'm going to talk to you about cities. Okay, so nullus locus sine genio. That's how the ancient Roman saying goes. And that means there is no place without a spirit. And it turns out that ancient Romans, as most often happens, were quite right. In fact, think about your experience of places in a city. So your experience of every place is determined by a number of little intangible things that make up for a good or a bad experience of that place, right? So today, what I'm gonna try to tell you is that it's very important for us to be able to measure quantitatively these little intangible things that surround us, and I'm going to show you how we can do that in an automatic way and at scale. So everything starts with the trend of urbanization, which most of you probably are familiar with. So by 2050, we know that more than 70% of the population on Earth will live in densely populated urban environments, basically in mega cities. And this trend calls for action, for some solutions that are actionable. Now, the smart city type of response to this trend is to maximize efficiency. It's the classic engineering point of view. So we increase efficiency of the transportation systems in our cities, of the energy management systems, and even in the way in which we manage the security of our streets by putting CCTV cameras all over. And those of you who live in London know this very well, right? So all these things might be good for a city. They might improve our experience of cities, but these are definitely not the elements that make the life of a city a happy life. And this is not something new, so this has been known for some time now. So if you look back at all the literature in the area of urban planning or even social psychology, and I'm thinking about the authors like Jane Jacobs, Stanley Milgram, and Kevin Lynch, so all these authors pointed out towards the same direction. To improve our experience of cities and to make us happy in a city, we need to understand the psychological perceptions of people living in cities, while you stand on a street, while you walk from A to B. If we can automatically understand your psychological perceptions, we can also build automatic tools that can improve these perceptions, all right? So this is actually what we've been trying to do for some time with some colleagues, and a few years ago we embarked in this quest that we call the quest for good city life, to make the life of city dwellers a happier life. And we started with this simple challenge. Can we measure at scale and automatically the beauty of a spot in a city? Okay? So now, I know what you think, that beauty is a very abstract and very subjective concept, but think about it this way. So if I show you these two pictures, picture A and B, these are two Google Street View pictures taken in London. Well, if I show this to a crowd, most of people would tend to agree that picture B is the most pleasant one to watch, right? And this is because we have a sort of shared experiences, shared notions of what beautiful things are, right? So, as humans, we are good in comparing things. So, what if we played this little game of comparison many, many times? So this is what we actually did a few years ago, building this website. It's called urbangems.org, where any person could go and play this little game. So you're shown two pictures taken from Google Street View in London, and you're asked to rate which one of the two was the most beautiful, appealing, visually appealing to you personally. Okay? We did collect data from thousands of players for tens of thousands of comparisons, and we could use an algorithm that takes all these pairwise comparisons and translate them into an absolute ranking, from the most beautiful picture to the least beautiful one. So now this is a very simple trick, but all of a sudden what we have done is that we have quantified beauty in a numerical way. Of course, it's averaged over many people, but it's something which is quantified, right? And we can look at the elements of the top and the bottom. Now, this is a neat exercise. The problem with this is that you need a lot of people labeling pictures, which is not really what we want to do because it doesn't scale. I am a computer scientist and I want to generalize solutions, right? And so we wondered, how can we scale this up? So we did it with social media. And that's because in social media you have a lot of user-generated content, you have pictures coming with a lot of metadata, for example, user-generated tags, and also precise geolocation, georeferences, okay? So that's the little trick we did. So taking the data from the game, the labels we collected from the game, we could build a training set where we have beautiful pictures rated as beautiful and, let's say, ugly pictures, ugly scenes in London. And we could run several algorithms, including, for example, machine vision on these pictures, and understand which were the patterns associated to beautiful scenes and ugly scenes. And so train a classifier that, given any new picture from social media, for example, could look at these patterns and understand whether the scenery depicted was a beautiful scenery or not. So all of a sudden, what we've done is we scaled the approach of assessment of beauty to the whole world, because given any social media picture, we can rate it in terms of beauty. The first application we came up with, given this technology, is called Happy Maps. In Happy Maps, you do the thing as follows. So given a point A and a point B on a map, if you take any routing application, also nowadays, what these routing applications do to you is they recommend you the path which is the most efficient from A to B. However, this path might happen to go through spots that are ugly spots, the red dots on the map, for example. So the very simple idea is, what if we compute a very short derive that, instead of passing through the ugly spots, passes through very pleasant locations? We just add a couple of minutes walking time on your experience, but your perception of the surrounding environment is going to be much better. Very simple idea. So we tested this with people walking around, for example, in Boston. Here we have a comparison with two routes. The blue one is the shortest, the red one is the beautiful one. People tried this out, and the feedback was extremely good. People say, yeah, I would totally sacrifice a few minutes more to actually have a better experience. And the feedback was in general good. However, people felt that there was something missing, something that was not captured yet. And that thing was very surprising to me. The element that, according to people, was missing was smell. Surprising, right? So people said, yeah, I might walk down a very beautiful alley, but maybe the smell of smog is too intense that I don't like it. Or even the smell of trash. Or even some positive comments saying, oh, you know, yeah, so that street I can go to work to, it's nice and beautiful, but I'd rather pass through a back alley where I can smell the smell of croissant or coffee from the local coffee shop, right? So smell impacts our experience of space as much as sight, as basically aesthetic appeal. And if you think about it, it's sort of right. And people who deal with cities think about smell. For example, municipalities think about odors, and especially bad odors, right? And the reason they do that is because they receive complaints from people complaining about the smell of trash, for example, right? The thing is that we don't want to focus on bad odors only, but we want to capture the full spectrum. And that's very hard, that's very difficult, because either you go around with a nasal trumpet to measure the concentration of different smells in the air. That's actually a real thing. This, you will reckon, doesn't scale, right? You cannot send the nasal rangers around in every street of the city to measure smell. Or again, we have to use some other paradigm, right? And this other paradigm, again, relies on social media and on previous literature. So what we did is we took some literature into the domain of what is called urban smellscapes, so people studying actual smells in the city. And from this literature, we came up with a taxonomy of urban smells. So here you have this wheel, which represents the taxonomy. In the inner circle, you have the main top categories. Then you have subcategories and some example words in the outer ring. Some categories include, for example, food, nature, and so on and so forth. Given this taxonomy, this set of categorized words, what we could do is, again, go back to social media. And in social media, you have pictures, and again, you have location for this picture, but also user-generated tags. And you can very trivially search for your smell-related words into the tags of these pictures. And these are pictures taken in India with words relating to fried food, so smell of food in that street. All right? So if you aggregate over all the millions of photos taken in a city, what you can build is smelly maps. Smelly maps is basically the smell profile of every single street segment of a city, and you can do it at a very granular level because there are many, many pictures submitted, for example, in a city like London. And you can say, on average, over the course of the year, this street smells 60% of emissions, so car emissions, 30% of food, and 10% of waste, for example. Okay? So now you understood a bit what the game is, and so one can say, oh, can we do the same for sound? The answer is yes. You can go and build taxonomy of urban sounds. Again, go back to social media, match your sound words with the tags, and you obtain chatty maps, again, which is profiles for sound in the city. Okay? Now, first thing that we should ask ourselves, is this working, is actually reflecting something that is happening at ground level, right? And the first thing that you can do is actually just to do maps, to look at all the emission-related pictures for smell, and see that if you draw all these pictures on the map, all the main streets and avenues in London pop up. If you do the same for nature, of course, many main bodies of water and parks will pop up. So these things sort of make sense. So people are taking nature-related pictures where there is nature, right? But you can also run some more systematic tests about this thing reflecting actual outcomes in real life. We run, for example, correlations with the presence of pollutants in the air, so NO2, PM10, PM2.5, with emission and nature-related smell words, where emissions positively correlates very strongly, and nature negatively correlates. So where there is nature, we don't find pollution, and the other way around. So just to tell you that there are several ways in which you can check that this thing is sound and ecologically valid. So if you're interested in this type of things, you can visit, or actually you should visit, this website that is called goodcitylife.org. And you will find very colorful maps there that you can play with, interactive maps. Here, for example, is a portion of the smell map of London, where you can click on every single street segment. If you live in London, you can try to find where you live and see what is the smell composition. And there are also other information, for example, the sentiment that is expressed in relation to those smells, and so on and so forth. All right? So over the years, in this website, we have collected a lot of projects that relate to mapping and urban analysis. In the years, we have drawn several maps. These are some of them. And most of them, you can see them on the website. Okay? I just wanted to mention a couple more, just very quickly, to give you a bit of a flavor of what you can do and what type of things also you can predict given this mapping from digital data. The first one is a map of culture. So using a paradigm which is very similar to the one I presented before, we mapped the main cultural assets in different London boroughs. And this is nice and neat. Your question might be, can we use this for anything? Well, it turns out that if you combine the cultural capital with the economic capital of a certain neighborhood, you can predict very reliably the price of rents in 5 years. Okay? So this analysis of the urban fabric through online data is useful to understand where these regions, these places in the city go in terms of economic development, for example. So here in this scatter plot, you have the predicted prices versus the actual ones in 5 years, and the R square is around 0.8. So another type of map we did is a map of food consumption. Here, actually, we're not talking about very intangible properties. It's very tangible. It's food. This we've done in collaboration with Tesco Labs, who provided us the data to basically visualize what Londoners eat during the course of 1 year. Here you have the map of fat consumed by people living in London. So you can see very strong spatial patterns here. And again, what you can do here is to try to predict whether people will be sick in different areas. So here you have a scatter plot in which every single dot is a neighborhood, an LSOA in practical terms, so basically areas of 2,000 people each. On the two axes, you have the diversity of nutrients that people consume. On the X, you have the average energy of the consumed items, so the calories, and the color corresponds to the levels, the prevalence of diabetes in these areas. And what you can see is that if you consume very high energy food and with very low diversity, the risk of diabetes is very high. And this happens even after controlling for social demographic factors, right? So these things that map online data into space are not just nice and good to look at because of these nice maps, but they're also useful to predict real-world outcomes. All right? So just to conclude, besides analytics and predictions, what we are interested in is also to deliver some value to stakeholders and different types of customers, right? I will give you just two final examples of how you can do that given the technologies I have described today. So this is about delivering some interventions or technologies to actual people. So the first example is about urban beautification, right? So we have our cities, and as we learn in our cities, we have beautiful and ugly spots, right? So how can we identify and make the ugly spots a bit better, right? So improve the visual appeal of our cities. So we launched this project. It's called Facelift. You can find it on goodcitylife.org. And the mission of Facelift is to basically beautify the city. So there's an example for Boston. And here in Boston, you can click on different hotspots. You can find the hotspots of ugliness, let's say, so not so beautiful spaces and places. And for every little dot, you can click on it, see on the left-hand side the current location as it is from Google Street View. And on the right-hand side, you can see the beautified version of the same scene using basically a generative model, a neural network model, right? So you can give to architects and urban designers some ideas on how to beautify a location. And this comes with statistics about which are the urban elements, for example, the sidewalks, number of trees, that they should modify to improve the visual appeal of the area, right? So that's the first example that goes towards architects. The second one that goes more towards the general public is about your daily habits, and in this specific example, your daily habit of running for those who are runners, right? So what we are trying to build now is this application, an iOS application, that works as following. So you are in any place in the city and you say, I want to run X kilometers, like 5 kilometers. And this application takes all the different layers that we have studied in the past that defines the smell and automatically computes the best circular route of length 5 kilometers that is the best for you, all right? So that's the type of value you can deliver to customers. So we were very happy in the past that this work received a lot of attention from the press, which doesn't really speak to the quality of the work, actually, but it speaks to the fact that people are very interested in these topics, because this is really capturing that spirit of the city that current technologies fail to grasp. So I want to thank all the bunch of my collaborators for many different institutions, and also thank you very much for your attention.